Hi, I'm Bill Metoyer, customer dealer contact. When Buick Marketing called and informed me that Buick Know-how wanted to do a program on the electrical system and they wanted to film the areas behind the dash, I knew immediately this information would be beneficial to the field. Not only does this know-how review current problems, but also the electrical problems that were encountered in our past models. This information should be very helpful and will aid as a quick reference tool. The Buick City Assembly Plant is also thankful that we could participate in making this training information possible.
At Buick City, our goal is to build the best car in the world. One of the ways we try to achieve that is we do numerous electrical checks as the car is going through the process. There's 7 checks before the car is actually complete to ensure the electrical system is intact.
Hi, I'm Chuck McLennan. In this program, we'll be talking about Park Avenue, LeSabre and Riviera service concerns. We'll be primarily dealing with electrical conditions. We worked with technicians at the Lake Orion and Buick City plants to collect the information for this program. As a matter of fact, we received so much input from the plant technicians that we've decided to split this program into 2 parts. The second part will be arriving at your dealership soon. The repairs for most of the conditions we'll be covering today are pretty simple. Most of the time, these problems can be corrected by repairing a damaged wire, splicing in additional wiring, or maybe just rerouting some wiring. Although the actual repairs for these conditions may not be complicated, identifying them can take a lot of time. This program will identify conditions and a few things that you should check while performing normal diagnosis. Let's start out with the MAL module. The plant has identified 2 concerns with the MAL module. The first is an internal problem with a capacitor that seems to be going bad. The only repair for this condition is to replace the MAL module. The second concern with the MAL is a tight fit at either of 2 electrical connectors. The 8-way connector requires a lot of force to engage fully into the MAL. Since the connector requires so much force to engage, you may not notice if pins are being bent during the process. The location of the MAL module makes connector engagement difficult. The module is located on a bracket behind the instrument panel. The MAL module also stores history codes and has its own diagnostics. To enter the diagnostic mode, turn the ignition on. Then press and hold the power unlock switch while cycling the headlamps off to on 11 times. Now that we're in the diagnostic mode, the MAL will provide feedback on history codes in the form of a chime. The seatbelt lamp will flash in sync with the chime. The MAL will chime once if there is a problem with the seatbelt lamp, twice if there is a problem with the battery protection system, and 3 times if any of the courtesy lamps are not functional. The MAL module cycles through these history codes 3 times with a 2-second pause before repeating. These history codes can be erased by holding the power door unlock switch for 4 seconds. If no codes are stored, the MAL will enter the input-output mode. This mode allows you to test individual inputs to the MAL module by cycling an input device. The MAL provides feedback by chiming when an input is cycled. The Know-how reference manual contains a complete list of MAL module inputs for this test. These MAL module tests will work for Park Avenue, LeSabre, and Riviera models. Now, let's look into some specific conditions on Park Avenue and LeSabre models. Conditions where the glove box lamp or switches are not operational can be caused by pinched wires at the lower left of the glove box. There is a screw in this location that is slightly too long. When it is installed during assembly, it can pinch the wiring in this location. The next condition is an inoperable brake transaxle shift interlock, or BTSI solenoid. This condition occurs on older Park Avenue and LeSabre models equipped with vacuum servo-style cruise control. The vacuum line going to the cruise brake switch may be misrouted and interfere with the BTSI solenoid engagement. Conditions where the rear side marker lamps are not operating may be caused by pinched or damaged wiring at the lamps. The grommet attached to the wiring used to be made of a rigid rubber. When the wiring was pulled through the pass-through, the rigid grommet would cut through the insulation. The plant is now using a new grommet that is made of a softer rubber to prevent this condition. Some intermittent electrical conditions on 1991 Park Avenue and LeSabre models may be caused by pinched wires at the relay center bracket. Check for pinched wires at the top of the relay center. Conditions where a front door speaker is inoperable can be caused by damaged speaker wiring. Wiring in this area can also affect courtesy lamps, power door locks, mirrors, and illuminated entry. The wires in this area can be pinched by the upper screw. Oftentimes, the wiring may be completely cut. This problem was corrected later in production by eliminating the screw. Conditions where the ABS fuse continually blows may be due to the anti-lock diode shorting out on the emergency brake pedal. If a chafed red wire from the diode touches the emergency brake, the anti-lock maxi fuse will blow. If a chafed white wire touches, the ABS lamp will illuminate, but no codes will be set. No start conditions with the security lamp on may be caused by pinched wires at the enable relay harness. The harness is located near the steering column bracket. An easy way to check for this condition without removing the instrument panel is to remove the driver's side speaker cover. When the speaker cover is removed, the enable relay and its wiring are exposed. Release any pinched wires and repair as necessary. Conditions where the ABS lamp is illuminated and wheel speed sensor DTCs are present may be caused by bent pins at the wheel speed sensor connectors. Bent pins can be readjusted for proper contact. Some intermittent electrical conditions on 1996 vehicles may be due to the PCM cover pinching wires at the two PCM harnesses. If the cover isn't installed carefully, it can pinch the wiring, which may cause various intermittent electrical malfunctions. Use care when reinstalling the cover. Extreme side-to-side temperature variations may be due to the flat pack wiring interfering with the motor's operation. When the wiring is caught in the motor, the HVAC doors are not able to open or close. Remove any wiring that is caught in the motor and reroute as necessary. Some intermittent electrical conditions may be caused by damaged wires at the 116-way connector. One of the screws that secures the hush panel can penetrate the harness. This can cause various electrical conditions depending on where the screw enters the harness. This problem was corrected during production by replacing the pointed screw with a flathead screw. When diagnosing conditions where the security lamp is always on, it's a good idea to start with the deck lid tamper switch. If the security lamp goes out, you've located the problem. This switch can be adjusted by turning the outer spring and sliding the shaft back into position. It's a good idea to monitor the switch status with the Tech 1 while adjusting the switch. Conditions where the airbag lamp is always illuminated may be caused by pinched wiring between the airbag pad and the bolt that secures the steering wheel in place. Repair and reroute the wiring as necessary. Fuel gauge inoperative conditions can be caused by damaged wires running along the floor pan by the driver's seat area. The harness runs through a conduit, except where it travels over the crossmember. Pay close attention to the gray and purple wires. Any damaged wiring should be repaired. It's also a good idea to cover the exposed wiring with electrical tape to prevent future damage. Conditions where all of the rear lamps are inoperable may be caused by a pinched rear lamp wiring harness. The wiring is being pinched by the bolts that secure the cargo net in the trunk area. Release any pinched wires and repair them if necessary. Plant technicians have reported instances where the Chimsel wiring harness is being pinched in the driver's side corner of the rear shelf area. This area of the rear shelf has a sharp edge that may cut the wiring. The regular brake lamps will still operate when this condition occurs. Some of the adaptive lamp monitors wiring may be damaged during installation of the defroster ductwork. The monitor rests near the ductwork and the steering column bracket. During installation, the monitor must be repositioned while installing the ductwork. If this is not done correctly, the wiring may become pinched. Conditions where the courtesy lamps do not work may be caused by staples pinching the headliner wiring. To correct this condition, the headliner wiring harness is now secured by wrapping tape around the harness and stapling the tape. Anti-lock brake concerns on 1996 vehicles may be due to backed out wires at the Bosch EBCM. The EBCM wiring harness may be routed too tightly. Over time, this can result in backed out or damaged wiring. Now let's turn our attention to some Riviera concerns. Intermittent electrical conditions in the instrument panel and door controls may be due to chafed wiring in the passenger door. Some of the wiring may be chafing on these studs. Repair and reroute the wiring to correct the condition. Intermittent brake and cruise control conditions can be caused by the brake switch wiring backing out of the connector. The brake switch must be rotated to install in its bracket. When the switch is being turned during installation, the wiring is pulled taut. This may cause some of the wires to back out from the connector. Some intermittent climate control conditions are caused by backed out wiring at the climate control programmer. Inspect and repair any backed out wiring as necessary. Conditions where the hazard flasher, brake lamps, BTSI, and cruise control are inoperable can be due to pinched wiring at the steering column bracket. Repair and reroute any damaged wiring to correct the condition. The plant has identified two areas of concern with the charging system. The first is that the generator harness is routed too tightly. The increased tension on the wiring can lead to damage over time. It's also a good idea to check the wiring beneath the engine cover when dealing with these concerns. If the wiring is mispositioned, it may be pinched by the engine cover. This condition is most likely to occur on 3800 supercharged engines. Problems with the MagnaSteer system may be due to the MISVA module. Some of the pins in the module have rough edges and are slightly out of spec. This can lead to bent pins when the connector is engaged. Repair this condition by bending pins back into place and reinstalling the connector. Loose DLC connectors may be due to the connector not fully engaging into the multi-use bracket. If the DLC is not locked into place, it can come loose when a Tech 1 is connected. The bracket was redesigned during production to prevent this condition. Some intermittent electrical conditions may be caused by backed out wiring at either one of the 80-way PCM connectors. Wires can back out when the PCM is installed into its carrier. When the PCM is installed into the carrier, it must be turned in a way that can put additional stress on the wiring. Windshield washers that cannot be turned off may be due to an over-advanced multifunction switch. When the switch is over-advanced, it can shear off teeth from the gear. Once a tooth is sheared, the driver will not be able to turn the wipers to the full off position. Replace the multifunction switch to repair this condition. The gear teeth have been slightly redesigned to prevent this condition. On vehicles where the low coolant lamp is always on, begin diagnosis by checking the coolant level. If it's okay, the problem may be due to a bad coolant level switch. Perform normal diagnosis and replace the coolant level switch if necessary. The final Riviera concern is a water leak condition due to the deck lid wiring. The wiring is getting caught in the weather strip towards the rear shelf area. While traditional style hinges allow the deck lid wiring to travel down the hinge into the trunk area, the Riviera uses a different style of hinge. The Riviera's hinges are mounted to the deck lid and trunk gutter. This prevents a direct wiring route to the trunk area. The wiring on the Riviera hangs from the deck lid into the trunk. If the wiring becomes misadjusted, it can rest on the weather strip, causing the water leak. The condition can be repaired by rerouting the deck lid wiring away from the weather strip. Now, let's take a look at some powertrain concerns. An injector fuse that continually blows may be due to an engine harness shorting out on the power steering pump bracket. On early model vehicles, the power steering pump bracket had a rough edge. This rough edge would make contact with the engine wiring harness and eventually chafe through the insulation. The result is usually a blown injector fuse. Currently, the edge of the bracket is machined during production to correct this condition. Misfire conditions on 1996 engines may be caused by fuel injectors 2 and 6 failing to pulse. This may be due to a tightly routed fuel injector harness. The increased tension on the wiring may cause it to break or become damaged over time. Keep in mind that you can use a Tech 1 to detect misfire conditions on all OBD2 equipped vehicles. These conditions can be fixed by repairing any damaged wiring. If necessary, splice additional wire to the injector. Other misfire conditions on these engines can be caused by a damaged or disconnected number 6 spark plug wire. The spark plug wire may be routed too tightly. This condition can be corrected by replacing the wire with one that is approximately 1 inch longer. Conditions where MAF sensor codes are continually setting may be caused by wiring that is routed too tightly. The tension on the wiring may cause it to break over time. Splice in additional wiring to correct this condition. In addition to using the Tech 1 to check for codes, it can also be used to monitor sensor status. To check for intermittence, you may want to move the MAP sensor wiring while monitoring it on the Tech 1. Conditions where the low oil pressure lamp is always on can be caused by a broken wire going to the 66-way connector. Plant technicians have reported instances where the black and white ground wire is broken. Oftentimes, the insulator is only stretched while the wire is broken. This can make diagnosing these conditions difficult. Throttle position and temperature sensor DTCs may be caused by a damaged engine wiring harness. The harness can be damaged by a clamp at the heater bypass hose. If the excess from the clamp makes contact with the harness, it may chafe over time. This condition was corrected during production by bending the excess off of the clamp. Later, the clamp was redesigned to correct this condition. Some no-start and intermittent electrical conditions can be caused by a damaged positive battery cable. One of the clamps securing the cable is slightly too large. The extra play in the clamp may allow the cable to slip and make contact with the harmonic balancer. Conduit was added around the cables to prevent this condition. Some other no-start conditions may be caused by pinched or chafed wires by the steering column bracket. This area of the harness was uncovered on early production vehicles. The wiring would get pinched when the instrument panel was installed. The wiring is now covered with electrical tape to prevent this condition. Another no-start condition can be caused by corrosion buildup in the 8-way engine electrical connector. After the engines are assembled, they are stacked one on top of the other. Sometimes coolant leaks from one of the engines and drips onto the engines beneath. This coolant may accumulate in the female end of the 8-way engine connector. Plant technicians have seen cases where this coolant causes the connector to corrode within 2 days. Inspect the connector and clean any corrosion to repair the condition. As you can see, Buick is constantly striving to improve the quality of our vehicles. The things we've covered today can really help when diagnosing concerns on these vehicles. Remember to refer to the Know-how Reference Manual for a complete list of the conditions and repairs. Oh, and don't forget, next month we'll be looking into some more concerns on Park Avenue, LeSabre and Riviera.